Hello everyone and welcome back to our so now let's proceed. I think you already know what we're going to do here. I think I already did mention that in our last video. So anyways, let's proceed. So here, let's proceed to the fourth problem. Hold on. There you go. Whoa, actually that's we have three more problems. But let's start first with this one. Find the coterminal angles for 50 degrees between 0 and 4 pi radians. It seems like what do you call this one? It seems like how should I say this? We have an angle in degrees, and these angles are not in degrees. So you have two choices here. Okay, you can either convert this one into radians, then your answers will be in radians. Okay, or convert this one into degrees, then let our answers be in degrees. Or you can do this way. Even if this one is in radians, okay, your answers could be in degrees and vice versa. Okay. So what I mean here is that your answers could be in radians, your answers could be in degrees, as long as they are equivalent to each other. You know what I mean? Okay. So it could be in degrees or what. So for me, I'd rather do it in degrees because I love degrees more than radians. Sorry, radians. Anyways, kidding aside, let's proceed. So with that, I would prefer these interval. I would prefer them to become in degrees. So 0 is just equivalent to 0 degrees. They're just the same. 4 pi radians is just the same as 720 degrees. All right. If you wish to know how I convert them, this one it's already obvious. 0 just the same as 0 degrees. 4 pi radians. Okay, remember, if you're going to convert a radian into degrees, you will multiply it by 180 degrees all over pi radians. So cancel out the radians, cancel out the pi's. What you have is 4 times 180 degrees. So multiply them. 4 times 180, this is 720 degrees. All right. So our interval would be from 0 degrees up to 720 degrees. Okay. So let's find the coterminal angles for 50 degrees within this range. So since I think it's positive here, you get me, and it's, how should I say this? What do you call this one? How should I say this? 50 degrees is within this interval. So we can actually get angles, coterminal angles of 50 degrees by adding 360 degrees. Because if we're going to subtract if we're going to subtract 50 degrees by 360 degrees, the answers would be negative. Like for example, 50 degrees minus 360 degrees will give you negative 310 degrees. So no, okay, it's not possible because the range is only from 0 to 720. So there's no negative angles here. So what we're going to do is we would rather just simply add the given angle by 360 degrees. So 50 plus 360, so this would be 410 degrees. So that's good because it is within the range of 0 degrees and 720 degrees. So, okay, we're good to go. Now, let's add this one by 360 degrees. So, add this by 360 degrees, 770 degrees. So, if you're going to observe, we only allow angles or coterminal angles to be particular within the range of 0 degrees to 720 degrees. Now, as you can see, we have 770 degrees, which is beyond that interval. So the answer would be no. Okay, it is not involved. The answer here is only 410 10 degrees. That is your final answer. Now, what will be the coterminal angle for 111 degrees when it rotated 3 times in clockwise direction? What will be the coterminal angle for 111 degrees when it rotated 3 times in clockwise direction? So here, you're going to find a coterminal angle for this one once it rotated 3 times in clockwise direction. So it's not about what will be the given coterminal angles, but rather what will be the exact coterminal angles. So we're only looking for one exact coterminal angle for this. So as you can see, it rotated 3 times, right? And it's in a clockwise direction. We have this formula. So for the given angle, we have this, okay? Initial angle or given angle plus 360 degrees K, okay? Or if it's in radians, so this is angle plus 2 pi radians times K, okay? If it's in radians. So since we are in degrees, so it's better to use this one. But if you wish to convert your final answer or these given into a radian, then make your answer into radian, then of course you would use this. Okay, if you wanted to put it in radians, okay? So we're going to use this one because this one's much more convenient. So your K is basically the integer. Okay, your K is an integer. I remember that. And this one tells you the number of rotations. Okay, the number of rotations. Okay, so this could be negative or positive. And how would you know if it's negative or positive? If it's negative, it is in clockwise direction. Otherwise, it would be positive. So now, how many rotations it formed according to the problem? So it's 3. Okay. Now, is it in clockwise or counterclockwise? It is in clockwise direction. So therefore, it is negative 3. Okay. So therefore, okay, let's substitute our given angle. By the way, it's 111 degrees, right? So we have 111 degrees plus 360 degrees times negative 3. So what would be our answer? 111 plus 360 times negative 3. So we have negative 969 degrees. That is our final answer. There you go. So that means after you rotated 3 times, in which it is a coterminal angle for 111 degrees, the answer would be negative 969 degrees. So that's it. Now let's go to our last problem for the coterminal angles. So here, what will be the coterminal angle for negative 500 degrees when it when it rotated 6 times in counterclockwise direction? So you have a given angle of negative 500 degrees, and your K would be what? Negative or positive 6? The answer is positive 6 because it's rotated in counterclockwise direction. Hence, you will use this formula. Initial angle plus 360 degrees. So initial angle is what? Negative 500 degrees. Plus, oh, wait, I forgot to put K, okay? Times K, right? I forgot. Plus 360 degrees times your K is 6. So here we will have the answer of negative 500 plus 360 degrees. Whoa. The answer is 1,660 degrees. So that will be your coterminal angle for negative 500 degrees when it rotated 6 times in counterclockwise direction. So that's it. That is your answer. Okay? So that is your answer. Now we're done with the problems involving coterminal angles. Let's now proceed to the next problem. So this one involves arc length. Find the arc length of a circle when the angle is 45 degrees and the radius is 20 centimeters. So remember that the formula of the arc length is S is equal to R times theta. But before we use this formula, you need to be aware of what? We're going to be aware of the angles. Okay? The angle. Because the angle should be in radians. Okay? So therefore, okay, if the angle here is in degrees, we must convert it into radians. How can we convert it again into radians? Multiply this one by pi all over 180 degrees radians. Okay? These two are both divisible by 90 degrees. 450 degrees divided by 90 degrees, this is 5. Because 5 times 90 degrees is 450 degrees. 180 degrees divided by 90 degrees is 2. Because 90 degrees times 2 is 180 degrees. So with that, we have 5 times pi. Whoa, okay, good. Pi all over 2 radians. All right, so here we will have 5 pi all over 2 radians. So that is the what? The angle for 450 degrees in radians. So we can now substitute. The radius here is 20 centimeters times the angle here, 5 pi all over 2 radians. We can simplify this one because you see 20 and 2 are both divisible by 2. So 20 divided by 2 is 10 centimeters and 2 divided by 2 is 1. So we're going to have 10 centimeters times 5 pi radians. So the answer here is exactly 50 pi centimeters. All right, we disregarded radian here because it is unitless, so we can just leave it be as our answer. But we need to approximate this one because you see, we're looking for the arc length. So at least by estimation or approximation, we need to know the length of this one because it has an irrational number of pi. So this is 157.08. 157.08 centimeters. So this is approximately, by approximate. So this is your answer. All right. So you can convert this one into kilometers, meters, inches. It's up to you. All right. As long as they are accurate to the answer here, or in short, equivalent to the answer. So we're good to go. Next, find the arc length of a circle when the angle is 13 degrees and the radius is 20 centimeters. Make the answer in kilometers. Okay, so it seems like we're going to convert this one into kilometers. Okay, so there are two ways. One is you need to convert your radius into kilometers. Or two, once you get your final answer, convert it into kilometers. Okay, so for me, I'm just gonna convert this one into kilometers. Right? Radius is equal to 20 centimeters. Recall that in 1 kilometer, this is equivalent to, 1,000, we have 1,000 meters, right? So 1,000, 100 centimeters. Okay, 100 no wait, 100,000 centimeters. There you go, 100,000 centimeters. Because you see, in 1 kilometer, I think you already knew that it is equivalent to 1,000 meters. And this is equivalent also to 10,000 decimeters. Okay? And this one is also equivalent to 100,000 centimeters. Okay? 1,000 centimeters. So with that, we're going to use this. Okay? Since we have centimeters here. So if you're going to convert this one into kilometers, what are you going to do? So since we're looking for the centimeters here, so what we're going to have is 1 kilometer above and 100,000 centimeters. Okay? Or what I just did here is an example of dimensional analysis. So here we can cancel the centimeters. And what we have here is what? 20 times 1 kilometers all over 100,000. This one I can simplify because 20 and 100,000 are both divisible by 10. So 20 divided by 10 is 2. And 100,000 divided by 10 is 10,000. But still, this could be divisible by 2 as well because 2 divided by 2 is 1 and 10,000 divided by 2 is 5,000. Hence, you have what? 1 kilometer all over 5,000. So this is exactly, 1 divided by 5,000. This is exactly, this is 0.1234. Yeah, this is 0.0002 kilometers. Okay? Or you can rewrite it in this way. 2 times 10 raised to negative 4 kilometers. But for me, I would prefer this one. Unless it reaches, let's just say, more than 5 decimal values. Oh my God, that would be different. So yeah, I would prefer this one. Okay, so this is your radius. All right. So once again, your radius. Okay. Remember the same formula. R times theta, your radius is 0.0002 kilometers times your theta is 13 degrees. Remember that we need to convert this one into radians since this is in degrees. So we have pi all over 180 degrees radians. Although I doubt that this would be divisible by any number except 1 because I have no other common factors for these two except 1 degrees. So what happens there is that we will divide these two numbers by 1 degree. So 13 degrees divided by 1 degrees is 13 only. And 180 degrees divided by 1 degrees, it's 180 degrees. Oh, no, 180. That's it. So our answer would be 13 pi all over 180 radians. So we have our answer. Okay. So here, oh yeah, by the way, you can also use the fraction form of this one, which I do believe it's 1 all over 10,000. I believe so. No, it's 5,000 if I'm correct. Yeah, 5,000. Am I right? 1,000 divided by 5,000. Yeah. You can use this one if you like to. Okay. So yeah, anyways, let's now get the answer. So 0.1234. So 0.00002 times 13 pi all over 180 radians. So the answer here, okay, I cannot see the exact answer here, but we can approximate our answer. The answer for this one is approximately 4.58. Wait, 4.58. Am I right? Yeah, 4.50. No. Wait, it's 4.54 kilometers. Wait. No. That's wrong. 4.54 times 10 raised to negative 5 kilometers. So this is your answer. Or, okay, you can rewrite this in decimal value. So 0.0.1234.5. So that is your answer. So either of these two, they're correct. Again, I mentioned earlier, there are two ways for you to answer this one. You either first convert your radius into kilometers or convert your final answer into kilometers. Okay? Hi, guys. So it's up to you because the answer would be the same. Okay? Or uh, approximately the same since we have decimal values here. So there's like a maximum error. All right? So let's proceed. Oh my God, I already spoiled you guys. But anyways, we're just going to answer them one by one, right? Okay, so, right. Sorry, I was looking at my time. So go on. Suppose the arc length is 150 inches and the angle is 5 pi all over 4 radians. What will be the radius of the circle? So we have the given arc length of 150 inches. And we have an angle of 5 pi all over 4 radians. Now we want to know the radius of the circle. So remember that we have this formula, right? So all we need to do is just substitute. So here we have 150 inches is equal to r times your angle, which is 5 pi all over 4 radians. That's it. So to find your r here, all we need to do is divide both sides by 5 pi all over 4 radians. All right. So the result, so this would be canceled. What we will have here is we have 150 inches all over 5 pi all over, oh, I have no space anymore. Uh, wait. I'll erase this one. Hold on. Okay. So what we'll have here is that 550 inches all over 5 pi all over 4 radians is equal to r. We can simplify this one. So 4 times 150. Wait, 4 times 150. We can simplify this one. So we can have 600 inches all over 5 pi radians is equal to r. Since we're looking for the r here, we can disregard the radians. Okay, since radians unitless. So here, what we will have is, I think this is 120. I do believe, yeah, 120 inches all over pi. Okay, because 605 pi are both divisible by 5. 600 inches divided by 5 is 120 inches, and 5 pi divided by 5 is pi. So that's it. All right. Now this is the answer, but we need to approximate this one. All right. So 120 degrees divided by pi, you have approximately an answer of 38.20 inches or 38.2 inches. It's the same, but yeah, this is your answer. All right, that's for the third problem. All right. So yeah, we're good to go. Now let's go for the last problem. So for the last problem, if the given radius of the circle is 11 millimeters and the given arc length is 4 meters, what will be the central angle that intercepts the given arc? So here you have the radius of 11 millimeters and you have an arc length of 4 meters. What will be the central angle? So you see, I think this is easy because here S is equal to R times theta. If S and R are given but theta is missing, so you will divide both sides by R so that you will have this one as your final working equation or answer, basically. But here's the problem. Your radius is in millimeters and this one is in meters. So they're not the same. It's like this actually. 1x plus 2x squared. Can you add them together? Okay, do you think the answer here would be 3x cubed? The answer is no. Okay, that's not correct actually. So rather, they should be in similar terms. So for example, 1x or x plus 2x. So with that, your answer will be 3x. So what's my point? My point is that they should be what? The same in terms of their units. It seems like they're different though. So what are we going to do? So you have two ways. First way is make these two into meters. So you're going to convert this one into meters. Okay? Or make these two in millimeters. So this one is in millimeters. So this one should be in millimeters as well. Okay? Or there's another way around. Okay? You can you can make these two as meters. Then when you, no, actually, no. There's only two way. Forgive me. There's only two way. So forgive me. So make these two as millimeters or meters. It's up to you. For me, I would rather do it in millimeters. Okay, for me. So what I'm going to do now is I'm going to convert this given arc length in millimeters. All right, so let me take a look. So here we will have S is equal to 40 meters. Then you see in 1 meter, it's equivalent to 1,000 millimeters. Okay, it is also equivalent to 100 centimeters, and it's also equivalent to 10 decimeters. So 1 meter is just the same as 10 decimeters. 1 meter is equivalent to 100 centimeters, and 1 meter is equivalent to 1,000 millimeters. Since we are converting this arc length into millimeters, so we're going to use this one, right? So yeah, so times a fraction. Since we are looking for the meters, so meters should be canceled. So the meter should be below. Then above should be the millimeters. So cancel the meters. What we'll have here is 40 times 1,000 millimeters. So the answer here would be 40,000. Wait, am I right? Yeah, 40,000 millimeters. So that is your arc length. Okay, 40,000 millimeters. Okay, so let me erase everything. Don't worry, I'm gonna rewrite the given. So your R is 11 millimeters and your S is 40,000 millimeters. So the problem now is the central angle. So use this formula. Okay. So we have arc length of 40,000 millimeters is equal to R, which is 11 millimeters. Okay. So to find your theta, we will divide both sides by 1 millimeters or 11 millimeters. So what happens, this would be canceled and we have meters on both sides, so this would be canceled. So exactly, this is your answer, 40 all over 11. However, I think it's better to, wait, I forgot. Don't forget to put radians because again, we are looking for the angle. So do not be confused if the number is not in angle or the number is not an angle. So if this answer is not just a ordinary constant, ordinary number, but it is an angle, so do not forget to put radian. Before that, if this number, okay, is in angle, but it's not in degrees, okay? So this is your answer exactly, okay? You can approximate this one because I do believe that, what do you call this one? I do believe that this is, how should I say this? Hard to understand. You get me? So, I mean, not hard to understand, but it's better to put it into numbers, whether if it's decimal or not, instead of just in fraction. So here we will have 40,000 divided by 11. So we have approximately 3,636.36 36 radians. So these are your final answers. And there you go. We're done. All right. There are some problems. Okay. There are some problems next here. So be patient with me because I think the next problems are still arc length, but after that, we will be having problems more on linear speed and angular speed. And after that, we can now proceed to the unit circle. Okay? If you don't want me to do this one, well, let's just say, okay, I'll take it with a grain of salt. It's okay. All right? Just wait until I upload the unit circle. Because if I uploaded that, you can watch it. All right? For now, I want you guys to have a practice. I highly encourage you to do so. All right? So that at least you have some improvement of mastering the subject.